Hey folks, once again we are back with IGCSE sequences and series. I'm going to speed up the process and I hope you guys you pick one or two things here. I'll periodically visit these concepts so you don't have to worry. If somewhere you don't pick it, continue replaying the video. I think the concepts will clear up with practice and replay. All right, thank you. Let's get back into the questions. All right, I've got a set of questions here. Um, these questions, we are interested in tackling the number patterns. So let's check together. Right, find the next term in each of these sequences. Well, what we'll do is first inspect if it's arithmetic. When we say arithmetic is we're having a common difference. So when we check, it looks like 4 all the time is being added. So we are interested in the next term. So next term is going to be 15 plus 4. That will give us 19. Yeah, let me check this one. Here it looks like we are subtracting 3, and it looks like we're subtracting 3 all the time. So it ends up being 1 minus 3. So the next term is going to be negative 2. Then the next term, next pattern, it looks like it's slightly different. If I see there, I start with 1, 9, 25, 49. It looks like these numbers, they are square numbers. And if I check carefully, it looks like we started with 1 squared, then we went to 3 squared, 5 squared, 7 squared. It looks like next it will be 9 squared, giving us 81. Then here are the first 5 terms in a sequence. So we have 4, 11, 18, 25, 30, it goes on like that. Now if I inspect, it looks like here we are adding 7 always. So the next term we are interested in adding 7. But here we're interested in expression of the nth term of this sequence. Because it's arithmetic, what we'll do is we say Tn is equal to what is common, which is not changing, is 7. And next to it we put n. But then what do? We test with the first position to say term 1 is actually 7 multiplied by 1, it will give us 7. But there we have got a 4. So what do we do to 7 in order for us to reach 4? We have to subtract 3. So it looks like in this pattern, we are from 7 and subtracting 3. So that's our formula or an expression for the nth term. It's actually 7n minus 3. Right, moving on. A solid has 6 faces, 8 vertices. Now, the moment it has 6 faces, we can come to think of it as a cube or a rectangular box. The shapes which have got 6 faces, and when we look at the vertices which are corners, we put 4 at the top, 4 at the bottom, so it makes them 8, and the edges, we've got 4 at the top, 4 at the bottom, and 4 sideways, so 4 times 3 gives us 12, so that's our solution for this part. Right, here is a sequence of diagrams made from identical square tiles. So if diagram 1, it has got a 1 there, there's 1 tile at the base, there are 3, there are 5. We expect to get 7 at the base for the diagram 4. On the grid, draw diagram 4. So, like I'm saying, anticipating to get 7 squares at the base. So 1, 2, 3, 5, 6, 7. Draw a square like this. Now, if we check vertically, the number here corresponds to the number of tiles going up. So we expect to have 4. It's 1, 2, 3, 4, like this. I think that's it for that pattern. Then next we are being asked to complete the table. So if we look at the table, they're saying we want to look at the number of tiles per diagram. So actually the pattern of the number of tiles, it looks like it's arithmetic, 1, 5, 9. We expect to get 13 there, and here we might get 17. So find an expression in terms of n for the number of tiles in diagram n. So it looks like all the time we are adding 4. So that will be Tn will be equal to 4n. Then we'll test with the first position like we did before to say if we have term 1, this is going to be 4 times 1, that gives us 4. But if we check here, we've got a 1. So what do we do to 4 to get 1? So we subtract 3. So on our formula, we also need to subtract 3. Then that becomes our formula for the nth term. Find the number of tiles in diagram 19. So that's using our formula, T19 is going to be equal to 4 multiplied by 19 minus 3. Well, 4 times 20 gives us 80. So it looks like this will give us 76 minus 3. So it looks like it's going to be 73. That will be the number of tiles in diagram 19. Then a box contains 98 of these tiles. Diagram X is made from as many tiles as is possible from this box. Find the value of X. So what are we saying? We are saying in a certain position, we've got 98 tiles, and we are saying this should be equal to our formula, which is 4n minus 3. Our interest is to say we want the value of um, x. So this is diagram X, so X corresponds to the position N. So if we want to actually match what's required by the problem, we are going to say 98 equal to 4x minus 3. And when I transpose there, I'll get 101 equal to 4x. And when I divide both sides by 4, um, it looks like I'll get 25. My x is position 25. And when diagram X is made, how many tiles are left? So when I say 4 times 25, it gives me 100. There are 101 tiles, so the remainder is going to be a 1. Yeah. Then we have another pattern there, 3541. For this sequence, write down the next term. Next term, we're not sure which type of pattern it is. If it's arithmetic, it means you're always adding 6. So we expect to get 47 here. Then the nth term, what are they saying? If this is position 1, then we are saying Tn is equal to 6n. 6 times 1, 6 times 1 gives us 6, but then there is 35. So from 6 to get to 35, it means this should be plus 29. Anticipating that is arithmetic. Then there is a pattern again. Write down the next two terms of this sequence. So if I check, I've got a difference of a 1 here, and then there's 3, 5, 7. I expect to get 9 there. So if I say 18 plus 9, looks like it will give me 27. Then I'll say the next it will be plus 11. So 27 plus 11, it looks like the next term is going to be 38. Describe in ways the rule for continuing this sequence. So we add an odd difference. So that's what we're doing. These are odd numbers. So that's the difference we are adding to get the next terms. I think, well, we have another one there. The nth term of a different sequence is 4n minus 3. Work out the first three terms of this sequence. So when n is 1, we are saying it's 4 times 1 minus 3. So the first one is 1. Then followed by when n is 2, 4 times 2, that's 8 minus 3. So it gives us 5. 4 times 3, that's 12 minus 3, it gives us 9. So those are the first three terms of that particular sequence. I hope you found this interesting. Quick sum on number patterns. Thank you.